Welcome to Section 1.5, the division of segments and angles. Our objective is to identify the midpoints, bisectors, and trisectors. In class, we're going to work on page 32 to 35, 2 to 20 evens, and 22 to 24 all. So let's get started with some definitions. So here we go. First definition that we have is of a bisector. A bisector is a line, ray, or segment that divides an angle or segment into two congruent angles or segments. Okay? Our second definition is of a midpoint. The midpoint is the bisection point of a segment. Now, can lines have a midpoint? Think about that and answer it tomorrow when we come in class. Next, we have the definition of a trisector. Two rays, lines, or segments that divide an angle or segment into three congruent angles or segments. And that's the definition of a trisector. So here we go. Let's draw a picture of each of these, including all necessary tick marks. Now, first, an angle bisector. First thing I'm going to do is I'm going to draw an angle, and I'm going to draw an obtuse angle. Although it can be any type of angle, I think it's easiest to do this for visual purposes with an obtuse angle. So there's my obtuse angle, and here's my angle bisector. For me, it's going to be a ray. It could be a line, it could be a segment. But what it's going to do is it's going to bisect my angle, making two congruent angles. And those are my tick marks showing congruency. Next, we have a midpoint. So I'm going to draw out my segment with endpoints. The midpoint is going to be a bisection point. It's a point which divides our segment into two congruent segments. And there's my tick mark showing my congruency. Next, we have an angle trisector. So again, I'm going to draw out an obtuse angle. For trisectors, we need to have two rays, lines, or segments that are going to divide this angle into three congruent angles. So there's one, there's two, and we need the necessary tick marks. I'm going to put doubles on each of these, showing my congruency. Last but not least, we have a segment trisector. For my segment trisector, I want to draw out a segment with endpoints. Now, with the segment trisector, I can have lines, rays, or segments that are going to go through and cut this segment into three congruent segments. I'm going to draw a segment here and a line here. Those trisection points are points on my segments. Now, we need to show congruency, so again, I'm going to double it up. I could triple it up. I can put little X's, but they have to have the same tick marks showing congruency. So here's my first example. We're given that AC bisects angle DAB. We want to know, does it also bisect angle BCD? Well, let's go ahead and let's highlight this over. Ray AC, which is going to be this ray right here, is bisecting angle DAB. Now, we're going to put in our tick marks here. What they're asking us is, does it also bisect angle BCD? Let's trace that over. BCD. I want you to think about that. What do you think? Does it bisect? Our answer is going to be no. All that we actually know about this is that it's bisecting angle DAB. We don't know anything about BCD, and we can't assume that because it bisects one, it bisects the other. LM is divided by K and P into the ratio 4 to 2 to 3. If LM equals 63, find LK and KP. Well, let's go ahead and let's draw this out. We know that this big segment here, LM, is 63. And we have it divided into the ratio of 4 to 2 to 3. Now, what we're going to do here is, since we don't know how big each one is, and instead of guessing, let's go ahead and let's put a 4x here, let's put a 2x here, and a 3x here. they tell us how it's divided. It's divided by K and P, so the order of the ratio should match the order in which we're seeing this. Now, let's go ahead and let's try and find out what LK and KP are. First thing that we're going to know here is that these three segments combine to make my longest segment, which is 63 units. So 4x plus 2x plus 3x equals 63. Simplify that and we get 9x equals 63. Solve for x and we're left with x equals 7. Now, to find out what LK and KP are, what we want to do is plug that back in. For LK, all we want to do is substitute in a 7, and that's how we get 48 for LK. And for KP, again we want to substitute in a 7, and that gives us 14. For my last example, we're given that MA bisects angle OMR. So here's angle OMR, and it's being divided into two congruent angles. We're given that that angle OMR, the big angle, is 137 degrees 45 minutes. We want to find the measure of angle OMA, one of these smaller angles. What we need to do here is we need to divide that angle by 2. Press pause and let's see what you can do. So here we go. When I divide this in half, that's going to end up giving me 68.5 degrees. And for my minutes, when I divide 45 in half, that's going to end up giving me 22.5 minutes. Now, we got to start swinging some pieces over. Starting with the half a degree, and then moving to my half a minute. Half a degree we know is going to be 30 minutes. Then we know that half a minute is going to be 30 seconds. That's going to end up giving me 68 degrees, 52 minutes, and 30 seconds as my final answer. So here's the answers to our homework. Again, for homework, we have 2 to 20 evens, 22 to 24 all. If you have any questions, don't hesitate to ask, and as always, have a good one.